Hello, everyone. I'm Ram, a principal systems developer with over 10 years of experience in building healthcare products, particularly in kidney care. Thank you for joining me today. I'm excited to explore artificial intelligence in incident management for dialysis healthcare, optimizing the response and reducing the system failures. Of the dialysis healthcare landscape, the prevalence. Dialysis is a critical treatment for millions of individuals suffering from kidney failure, a condition that is becoming increasingly common due to rising rates of chronic diseases such as diabetes and hypertension. The World Health Organization estimates that over 2 million people globally are on dialysis, a number that is expected to grow as these underlying health issues become more prevalent. This trend emphasizes the urgent need for the effective kidney care and management strategies. Coming to the types of dialysis, there are two primary types of dialysis, the first one being hemodialysis. This method involves filtering the blood through a machine called dialyzer, which acts as an artificial kidney. Blood is drawn from the body, cleaned, and then returned. Hemodialysis typically occurs in a clinical setting, with sessions lasting about 3 to 5 hours, several times a week. The second one, the peritoneal dialysis. In this method, the abdominal lining, also known as peritoneum, is used as a neural filter. A dialysis solution is introduced into the abdominal cavity, where it absorbs waste products from the blood through the peritoneum. This type can be done at home and offers greater flexibility in terms of schedule. The settings. The dialysis can be performed in various settings. Some of them could be hospitals, often the primary location for patients requiring the acute care or those starting dialysis. Dedicated dialysis centers, specialized facilities that offer a range of dialysis services, typically staffed by trained professionals. At the home, an increasing number of patients are opting for the home dialysis, which allows for more independence and can improve the quality of life. Home dialysis options, especially peritoneal dialysis, enable patients to manage their treatment in a familiar environment. Coming to the cost, the financial burden of the dialysis can be significant. Treatment can be costly, with expenses related to equipment, supplies, and healthcare personnel. Many patients rely on government healthcare programs, such as Medicare in the US, or private insurances to cover these costs. However, the financial implications can still be overwhelming, particularly for those without the adequate coverage. The importance of effective incident management in patient care. These would cover the patient safety. Effective incident management is crucial for maintaining patient safety in dialysis care. Rapidly identifying and addressing errors or near misses helps to prevent harm for the patients. For example, timely interventions can prevent complications related to the dialysis access sites or machine malfunctions, ensuring that patients receive safe and effective treatment. Quality improvement. Analyzing incidents that occur during dialysis treatments is vital for identifying systematic issues within healthcare practices. By examining these incidents, healthcare providers can implement strategies to improve process, enhance training for staff, and establishing protocols that manage and minimize the risk of future occurrences. This focus on continuous improvement ultimately leads to better patient outcomes and increased trust in the healthcare services. Moving to the risk mitigation, proper incident management not only enhances patient safety but also reduces liability and potential legal consequences for healthcare providers. By having robust procedures in place for reporting and managing incidents, facilities can demonstrate their commitment to quality care, which may help in mitigating the risks associated with the malpractice of claims or regulatory scrutiny. Effective risk management fosters a culture of safety and accountability, benefiting both patients and the healthcare professionals. Understanding the incident management. Incident management in healthcare is a critical process designed to enhance the patient's safety and the care quality. It involves a systematic approach to identifying, reporting, analyzing, and responding to the adverse events, the near misses, or unexpected occurrences that can impact patients or the healthcare system. By establishing a robust incident management framework, healthcare organizations can improve outcomes, minimize risks, and foster a culture of safety. Coming on to the incident management process itself, the incident management process typically includes several key steps. Some of them could be the detection and reporting of the incidents. Talking about the detection, the first step involves recognizing when an incident occurs or is it about to occur. This can be achieved through monitoring systems, the staff observations, or patient feedback. And then the reporting. Once detected, incidents should be promptly reported. Many organizations utilize standardized reporting systems or electronic tools that allow staff to document incidents easily and confidentially. Encouraging a culture of transparency and non-punitive reporting is essential to capture all relevant events. The initial assessment and prioritization. After an assessment is reported, it undergoes an initial assessment to determine its severity and impact on patient safety and care quality. These steps involved classifying incidents based on their potential or actual consequences, enabling prioritization for investigation and response. Investigating the root cause analysis. A thorough investigation follows, involving a detailed examination of the incident to gather facts and understand what happened. This may include reviewing the patient records, interviewing staff, and analyzing the workflows. Coming to the actual root cause analysis, the investigation aims to identify the underlying causes of incident rather than just addressing the surface level issues. RCA techniques such as the 5 whys or the fishbone diagrams help teams to uncover systematic factors contributing to the event, enabling them to tackle root causes effectively. The implementation of corrective actions. Based on findings from the investigation, corrective actions are developed and implemented to prevent recurrence. These actions might include the policy changes, staff training, process redesign, or enhancements to equipment or technology. The goal is to create sustainable environment in practices and the protocols. Monitoring and the evaluation of outcomes. After corrective actions are implemented, it's crucial to monitor their effectiveness over time. This involves the tracking of outcomes and analyzing whether the changes have resulted in a reduction in similar incidents. Ongoing evaluation ensures that the improvements are embedded within the organization and that any new issues are promptly addressed. Sharing of lessons learned. One of the most important aspects of incident management is the dissemination of lessons learned from each incident. Sharing insights across the teams and departments fosters a culture of continuous learning. This can be accomplished through regular meetings, training sessions, or organizational newsletters, ensuring that all staff members are aware of findings and best practices. The key components of incident management. So the incident management process can be broken into 4 key components that are the detection, reporting, and response, and then the recovery from what we discussed above. The current challenges in dialysis healthcare. The dialysis healthcare landscape faces several pressing challenges that impact the patient safety, care quality, and operational efficiency. Among these, high patient volumes and increasing complexity of cases are particularly significant. So, discussing the high patient volumes and complexity in detail, the overcrowding. So, in many healthcare settings, especially hospitals and emergency departments, there is often an influx of patients requiring dialysis. This can lead to overcrowding, where facilities struggle to accommodate the number of patients needing treatment. Also, the long time waits. Overcrowding typically results in an extended wait time for patients. Delay in treatment can exacerbate the existing health issues, leading to worse outcomes and increased patient dissatisfaction. Patients may experience anxiety and frustration due to uncertainty over their care timelines. Increasing complexity of cases. Many patients undergoing dialysis have multiple comorbid conditions, such as diabetes, cardiovascular disease, and other chronic illness. This complexity requires tailored treatment plans and close monitoring, straining resources, and increasing the likelihood of complications. The varying needs. Each patient's situation is unique, necessitating individualized care. Healthcare providers must navigate varying medical histories, medication interactions, and lifestyle factors, which can complicate the delivery of consistent and effective care. The frequent equipment failure and patient complications. Critical devices used in the dialysis, such as the dialysis machines, infusion pumps, and monitoring equipment, may be more prone to malfunction in busy healthcare environments. Increased usage can lead to wear and tear, making equipment reliability a crucial concern. So, the heavy demand placed on the dialysis equipment can disrupt regular maintenance schedules. When maintenance is deferred or inadequately performed due to high patient volumes, the likelihood of equipment breakdowns increases, potentially compromising the patient care. This could also lead to the patient complications and increased incidences. For example, high patient volumes can lead to more frequent complications such as infections, vascular access issues, and electrolyte imbalances. These complications may arise from rushed procedures or insufficient monitoring due to staff being stretched thin. The interplay of the overcrowding, equipment failures, and the complexity of patient cases creates an environment where patient safety is jeopardized. Increased errors, overlooked details, and the delayed responses can significantly affect the care quality and outcomes. Coming on to the impacts of the patient safety and care quality, the challenges stemming from high patient volumes, equipment issues, and complex cases have profound implications for patient safety and care quality. Some of them could be the diminished care quality, increased risk of adverse events, staff burnout, and the patient experience. With this setting, let's talk about the role of artificial intelligence in the AI healthcare. First, the definition of AI and its relevance in healthcare. The artificial intelligence, as we know, is defined as the development of computer systems capable of performing tasks that typically require human intelligence. This includes abilities such as visual perception, speech recognition, decision making, and language translation. In the context of healthcare, AI is increasingly recognized as a transformative tool that enhances the patient care, improves the diagnostic accuracy, streamlines the operational process, and advances the medical research. By leveraging AI technologies, healthcare providers can make more informed decisions, reduce errors, and optimize the resource utilization, ultimately leading to better patient outcomes. Moving on to the overview of AI technologies and healthcare, AI encompasses various technologies, each contributing uniquely to the healthcare landscape. One of them is the machine learning, where a subset of AI machine learning, which is a subset of AI machine learning, involves algorithms that enable computers to learn from learn from and make the predictions based on data without explicit programming. Coming to the applications in healthcare, the machine learning can be used for predictive analytics, identifying the patterns in patient data to foresee potential health risk. And the other term could be the deep learning, where a more advanced form of learning, deep learning, utilizes neural networks with many layers to analyze vast amounts of data. And then the natural language processing. The natural language processing is a branch of AI that focuses on interaction between computers and the human language, enabling machines to understand, interpret, and generate human language. The computer vision. The computer vision enables machines to interpret and process visual information from the world, similar to how humans perceive and understand images. And the last one is the data analytics. Data analytics involves the systematic computational analysis of data to uncover the patterns, trends, and the insights. Healthcare and overview. So AI is revolutionizing the healthcare by providing innovative solutions across the various fields. And let's look at the details on how the current applications of AI is helping in several key healthcare areas. One of them is the radiology and medical imaging. AI algorithms, particularly those using the deep learning, are being employed to analyze the medical images such as X-rays, MRIs, and the CT scans. These algorithms can identify abnormalities such as tumors, fractures, other pathologies with high accuracy, often comparable to the exceedings that of human radiologists. Prioritization of the urgent cases. AI can enhance radiology workflows by prioritizing the urgent cases. Algorithms can flag the images that require immediate attention based on the specific criteria, allowing radiologists to focus on the high risk patients first. 3D image reconstruction and visualization. AI technologies that are capable of reconstructing the 3D images from 2D scans, enabling healthcare providers to visualize complex anatomical structures in 3 dimensions. Moving on to the oncology, it helps in the personalized treatment planning, cancer detection in pathology slides, and also prediction of the treatment outcomes. Also in the cardiology, it helps in the ECG analysis, predictive models for the cardiovascular risk assessment, and the AI-assisted echocardiogram. Let's talk about the AI applications in the incident management. AI is playing a pivotal role in enhancing the incident management within the healthcare settings. By leveraging advanced technologies, healthcare organizations can improve patient safety, streamlining operations, and respond more effectively to adverse events. Here is an in-depth look at 3 key applications of AI in incident management, which are the predictive analytics, the real-time monitoring, and the automated reporting. Predictive analytics. Predictive analytics in healthcare involves the usage of historical data, the statistical algorithms, and machine learning techniques to forecast potential incidents before they occur. By analyzing the patterns from the past incidents, healthcare providers can identify risk factors and trends that may lead to the future adverse events. The benefits could be the proactive safety measures. By anticipating the potential incidents, healthcare organizations can implement preventive measures. Then the resource optimization. Predictive analytics can help allocate resources more effectively by identifying the times or departments at higher risk for incidents. And then it helps in the improved patient outcomes. Anticipating incidents enable healthcare providers to intervene early, reducing the likelihood of complications and enhancing overall patient safety. Moving on to the real-time monitoring, it involves the continuous collection and analysis of data from patients and medical equipment. This can include vital signs, the lab results, and operational status of medical devices. AI algorithms analyze this data to detect issues as they emerge. The benefits could include the immediate issue detection, enhanced equipment performance, and the data-driven decisions. And the last one, the automated reporting. The systems leverage AI to streamline the communication of critical information during the incidents in automated reporting. These systems ensure that relevant data reaches appropriate stakeholders quickly and effectively. The benefits could include the rapid information dissemination, standardization of the reports, and enhanced collaboration. Let's dive deep into the predictive analytics. Predictive analytics is transforming healthcare by leveraging data to forecast future events or outcomes, enabling proactive interventions and helping making informed decisions. So, through the use of statistical techniques and machine learning, predictive algorithms can analyze historical and current data to provide valuable insights. Here is a detailed overview of how these algorithms work and some common applications in healthcare. So, some of the features could be the data collection, the feature selection, model training, model validation, model deployment. Let's talk about some of the examples of the predictive models used in healthcare, which are readmission, risk prediction, or the sepsis prediction, chronic disease progression, medical adherence, and the emergency department utilizations. On to the real-time monitoring technologies in dialysis. The integration of sensors and the IoT, Internet of Things, devices in dialysis has transformed the management and delivery of these critical treatment for patients with kidney failure. These technologies not only enhance the efficacy of dialysis, but also improve patient safety and optimize the overall treatment process. Here is a detailed overview of 3 key real-time monitoring technologies in dialysis, which are the overview of sensors and IoT devices. in dialysis, which helps in the fluid balance sensors, bioimpedance sensors, or clinical applications, or the weight sensors. And then the next ones could be the dialysate composition sensors, which helps in the conductivity sensors for the clinical applications. We could also monitor the pH and then also the the temperature sensors. Some of the benefits of continuous monitoring for patient safety could include the early detection of the complications, which is possible by continuously monitoring, continuous monitoring enabled by the sensors that allow for immediate identification of potential complications. And then we could also detect the rapid fluid shifts and the blood pressure changes and also the electrolyte balances, which helps in the proactive intervention. The ability to monitor patients in real time allows healthcare teams to intervene proactively before complications escalate. Early identification of issues enable timely adjustments to treatment plans, medication administration, and the other interventions. So let's look at a case study for the predictive analytics in action. So let's take the example of the SmartCare Dialysis Center in AI implementation. So let's take SmartCare Dialysis Center is a medium-sized facility equipped with 30 dialysis machines, providing essential treatment to approximately 120 patients. The center faced significant challenges due to recurring equipment failures, which not only disrupted the treatment schedules but also posed potential safety risks for patients. To mitigate these issues, the center decided to implement an AI-powered predictive maintenance system aimed at enhancing the operational efficiency and ensuring patient safety. So here, the AI implementation could help in the data collection, predictive analytics model development and real-time the deployment and real-time monitoring. And then from all of these, whatever the results we get and the benefits that could include reduction in equipment failures, improved treatment continuity, the enhanced patient safety, and operational efficiency. Automated incident reporting. Automated incident reporting is a transformative approach in healthcare that leverages artificial intelligence to streamline the documentation process for adverse events, near misses, and other clinical events. This automation not only enhances efficiency but also improves accuracy and compliance in reporting. Here is a detailed look at how AI can automate clinical incident documentation through real-time data capture and intelligent form filling. So some of them could be the real-time data capture, which can be achieved through continuous monitoring of the medical devices, the patient vital signs, and the environmental factors. And then the automated data collection. When an incident occurs, the AI system automatically captures the relevant data points at the exact time of event, which could include the time and date of the incident, specific reading from the medical devices, environmental conditions, etc. With that, the benefits of real-time data capture could include the immediate documentation, where it provides the ability to capture the data at the moment an incident occurs, ensures that critical information is not lost or forgotten, which improves the readability of the report. And also it helps in the comprehensive insight. By collecting the data from multiple resources, the AI provides holistic view of the incident, helping to identify contributing factors and the trends. It also helps in the the reduced burden on the staff. Automating the data collection process alleviates the documentation workload on healthcare professionals, allowing them to focus on the patient care. And then also the other key feature could be the intelligent form filling, where we could take the advantage of natural language processing, which helps in the transcription of the voice notes, the automatic population of the standardized forms, and filling out the required fields that are needed for the treatment. And the benefits of the intelligent form filling could include the enhanced accuracy, and then the time efficiency, which saves a lot of time, and then the streamlined reporting process. So basically, automated reporting facilitates quicker analysis and review of the incidents, helping the organizations to identify trends and implement corrective actions more effectively. The benefits of AI in dialysis incident management. The integration of AI in dialysis incident management significantly enhances patient safety, care quality, operational efficiency, and resource allocation. So here, let's explore some of the benefits, focusing on early detection and prevention as well as optimized scheduling. So enhanced patient safety and care quality, which could cover the early detection and prevention through the continuous monitoring and predictive alerts. Let's take a look at the example. In a practical scenario, if an AI system detects sudden changes in a patient's blood pressure trend during a dialysis session, it can generate an alert for the healthcare team. This proactive measure allows the staff to intervene early, adjusting fluid removal rates or providing necessary medication before a hypertensive episode occurs, thereby preventing complications and ensuring patient safety. Moving on to the improved operational efficiency and resource allocation, it helps in optimized scheduling based on a dynamic schedule instead of a static scheduling and resource matching. We don't need to do a manual resource matching. AI could take care of doing that resource matching, so that also helps. So, for example, if you take an instance where a patient is known to require longer treatment times due to complications or unique medical needs, the AI systems can dynamically schedule their appointment to a less busy time slot. This adjustment not only minimizes wait times for all patients, but also improves overall patient flow and satisfaction. On to the implementation considerations for AI in healthcare. When integrating AI into healthcare systems, particularly in sensitive areas like dialysis management, several critical considerations must be addressed. Among these, data privacy and security issues, as well as integration challenges with existing systems, are paramount. Below is an elaboration on these key considerations. Some of them could be patient, like as we talked, the data privacy and security issues, which could cover the patient data protection, where we need to follow the HIPAA compliance. And then this could include implementing policies and procedures that ensure the confidentiality, integrity, and the availability of protected health information. And then the data encryption, implementing end-to-end encryption is critical for protecting patients' data, both in transit and also at rest. This means that data is encrypted before it is transmitted over networks and remains encrypted while stored on the servers. The access control. Establishing strict role-based access controls to the RBAC, which is commonly known as RBAC, is vital for limiting the data exposure. RBAC ensures that only authorized personnel can access the specific data based on their job roles and responsibilities. Moving on to the integration challenges with the existing systems, one of them could be the interoperability issues, where the data format standardization, right? One of the significant challenges in implementing AI healthcare is ensuring that the new system can effectively interpret and utilize the data from various existing healthcare IT systems. Many legacy systems may use different data formats, making it difficult for AI applications to process information seamlessly. The other could be the API development, where developing robust application programming interfaces, which are also commonly known as APIs, is essential for facilitating seamless data exchange between the new AI systems and legacy platforms. API serves as a bridge that enable different software applications to communicate with each other, allowing for the faster transfer of data without significant disruptions. Now, to addressing the ethical concerns in AI development, the development of artificial intelligence in healthcare, particularly in sensitive areas like dialysis management, raises several ethical considerations. These concerns primarily revolve around patient autonomy, informed consent, access, and the potential for bias in AI algorithms. Addressing these issues is critical in building trust and ensuring that AI technologies enhance patient care without compromising the ethical standards. Talking about the patient autonomy and informed consent, this could be achieved through the transparency and the opt-out options. And then moving on to the ensuring equitable access and avoiding bias in AI algorithms, we could train the AI with the diverse data sets so thereby achieving the equitable access. And then also considering the representative sampling, the data audits, etc., that could help in getting the better results. The future trends in AI and dialysis healthcare. So AI continues to advance. Its applications in healthcare, particularly in dialysis management, are becoming increasingly sophisticated. One of the most promising areas is natural language processing, which focuses on interaction between computers and human through the natural language. So this could be considered as one of the emerging technologies, which is the natural language processing. It is rapidly evolving. It is a rapidly evolving branch of AI that allows computers to understand, interpret, and generate human language. Its significance in healthcare lies in enhancing the communication, improving the documentation and processes. The key advancements in NLP lately are the improved semantic understanding. The multilingual capabilities is another big improvement in this area lately. So coming to the applications in the incident management, the natural language processing capabilities are particularly beneficial in incident management within the dialysis healthcare, where timely and accurate documentation can significantly impact the patient outcomes. Some of them could include the automated documentation, clinical note analysis, the patient complaint, and the patient complaint processing. Moving on to the collaborative AI systems, the integration of AI into healthcare, particularly in dialysis, necessitates the formation of collaborative AI systems. These systems leverage the expertise of interdisciplinary teams to maximize the effectiveness of AI technologies. Here is some details where the collaboration could help. The first one being the diverse expertise integration, where we go with a multifaceted approach to fully utilize the AI capabilities. It is essential to adapt to a multifaceted approach that draws from the various disciplines. The next one could be the team composition. Like we in a dialysis healthcare system, we could have a team composition with nephrologists, nurse, technicians, data scientists, AI specialists, ethicists, and then the ID professionals with within one setting, so which could also help. But if we take an example, in developing AI, an AI-driven fluid management system, nephrologists can offer insights into the clinical implications of fluid balances in dialysis patients. Data scientists would be responsible for designing the algorithms that predict fluid needs based on the patient data, while nurses provide feedback on how the system can be integrated into the daily practice. This collaboration ensures that the final product is clinically relevant, technically robust, and user-friendly. Enhancing the communication and collaboration among healthcare providers. This could be achieved through shared understanding or the common language development, interdisciplinary training sessions, etc. Looking at an example, organizing monthly AI nephrology seminars can serve as a platform where team members present on a range of topics. For instance, a data scientist might explain the basics of machine learning while a nephrologist discusses the clinical dialysis challenges. Such lessons foster knowledge sharing, enhance the team cohesion, and encourage collaborative problem solving. With all that discussed, coming to the conclusion, as healthcare systems increasingly adopt artificial intelligence technologies, the potential for transformation in the incident management becomes increasingly evident. AI's capabilities offer profound improvements in patient safety and care quality, particularly in areas like dialysis. Let's take a quick recap of the transformative potential of AI in incident management. The first one being enhanced predictive capabilities, where we could achieve the early detection with the help of the AI algorithms that analyze the vast amounts of data, and the risk stratification. Advanced modeling techniques allow for categorization of patients based on their likelihood of experiencing complications. This risk stratification enables healthcare providers to tailor monitor and treatment strategies according to individual patient needs. And the next one being the real-time monitoring analysis, which could be achieved through the continuous assessment and anomaly detection. So again, with all that, to summarize in a final thought, the integration of AI into incident management represents a paradigm shift in healthcare, offering enhanced predictive capabilities and real-time monitoring that significantly improve patient safety and care quality. By leveraging AI's power to detect early warning signs and analyze data continuously, healthcare providers can act proactively rather than reactively, leading to better patient outcomes and a more efficient healthcare system. As these technologies continue to evolve and become more widely adopted, their role in incident management will likely grow into a new era of precision medicine and the patient centered care. Thank you. Thank you for your opportunity to share this information with you. I hope you found it valuable, and I am here to answer any questions you may have. Thank you.